Welcome to Desai Academy of class 9th, chapter number 2 is matter around us pure. Okay, in a previous video we discussed that separation of mixtures by distillation method and another is what fractional distillation method. These are the two methods we are discussed in a detailed manner in our previous videos. So you want videos of this chapter means please search in our playlist, you will got all the videos of this chapter. Okay, next we'll discussing that another method, how can we obtain different gases from air. Okay, I already know that air is a what, a mixture of several gases, correct. Air is a mixture of several gases. So air is a what, a mixture of several gases. In that air, not only the gases is there, so tiny particles and dust particles, a lot of substance are mixed in the air. So from that, how can we differentiate, how we can separate gases from the air, right? So which methods are suitable? Air is a homogeneous mixture, right? A homogeneous mixture. Air is what? A homogeneous mixture and can be separated into its component by fractional distillation method. Okay, air is a what, a mixture of several things. Already I said that the gases, tiny particles, dust particles, right? So they can be separated by which method? Fractional distillation method. They using which method? Fractional distillation method. The flow diagram, okay, the flow diagram has flows here. So first air is there, correct? Air. So compress and cool by increasing the pressure and decreasing the temperature. So okay, remember that when air is there, the air should be converted into liquid air. You have to increase the pressure, you have to increase the pressure and decrease the temperature. Remember that you have to, okay, for 1 marks they will ask how we can convert the liquefied air. Means you have to increase the pressure first and you have to decrease the temperature. You have to decrease the temperature and increase the pressure. We can convert the gases in the air, we can convert them into liquid form. Okay, how? By increasing the pressure, by decreasing the temperature, we can easily convert gases in the form of air to the gases in the form of liquefied air. So remember that how gases are converted into liquefied air means by increasing the temperature and by increasing the pressure and by decreasing the temperature. By this method we can easily convert gases in the air into liquefied air. Remember that by increasing the pressure, by decreasing the temperature. After that the air is liquefied. So next, what is the next step? Means allowed to warm up slowly in a fractional distillation column. After the liquid is after the liquid air is present, or we are converted air into liquid air, so that should be warm up in what, a fractional distillation column. After that different boiling point, we can separate the gases from the air. Okay, so different boiling point, oxygen is having different boiling point minus 183, so it will be removed from the air very easily. After 183 the argon will be removed and nitrogen 196 degree. Different different at the boiling point, different gases are what, removed from the air, called by the method of fractional distillation method. Okay, this is the method of separation of air. So how we can liquefy the air? By increasing the pressure. Remember that by two factors, by increasing the pressure and by decreasing the temperature. Remember that we have to increase the pressure and we have to decrease the temperature, then only we can convert mixtures of air into liquefied air. These are the two methods. Okay, So if you want oxygen gas from air, so you have to separate out all the other gases present in the air. Okay, so already we learned that air is a what, a mixture of several gases, correct? Air is a mixture of several gases. It contain variety of gases like nitrogen, oxygen, carbon dioxide, a variety of gases is there. It is a mixture of several gases, so you have to obtain the oxygen, then you have to separate remaining other gases present in the air, right? The air is compressed by increasing the pressure and is then cooled by decreasing the temperature to get a liquid air. Okay, how will get the pure gas from the air means, so first you have to increase the pressure. By increase the pressure and increase the pressure, correct? By increasing the pressure, so the air will get very heated. So after that we have to cool down. We have to cool down the air by cooling the, by decreasing the temperature. By decreasing the temperature, first we will take the first we will doing increasing the pressure on the air, and after that it should be cooled down by the decreasing of temperature. This is the method. This liquid air is allowed to warm up slowly in a fractional distillation column. After we giving the more pressure, and after that it will be cooled by decreasing the temperature, and after that it should be allowed to cool down in a fractional distillation method. Okay, so in after cooling, after conversion of air to liquefied air, it will be cooled down in a fractional distillation column, right? Where gases get separated at different heights. Okay, after that the gases are separated different heights according to their boiling points, depending on their boiling point. Which one is having a less boiling point, that should be very easily separated, and as the boiling point is increasing, they will be laterally or separated from the air. So depending on their boiling point, it will be very easily separated. For example, here one is a 90 degree, one is a 80 degree, another is 100 degree. Means first the 80 boiling point of the element will be removed very firstly, after that 90 element, after that 100 degree boiling point. So okay, depending on the boiling point, the gases are removed according to that only, and laterally so we will get our required element. So next we'll discuss that how oxygen is separated from the air. So this diagram is illustrate completely detailed manner how the oxygen will be removed from the air. So first you have to take the air and you have to filter, and the filtered air is passed through the water under high pressure of air. So first we will take the air and will pass it through. We have to filter first we have to filter the air, and filtered air is passed through the high pressure region, and the air will be pressurized, and the pressurized means they will get hot, the hot air will is passed through the water in a cooler. Okay, first what we done here, we have taken a filtered air, means you have to first we have to take a air from the atmosphere and you have to filter it, and you have to pass to the water pressurized region. The pressure will applied on the air, and the air becomes hot, so that hot air will pass through the water, freezing cold water. Okay, this will be how to cool down, so it will pass through the cold water, right? And the cold compressed air will passing through this component, and it will pass it through the water separator. First air is passing through the pressure region, after that the hot air is passing through the water freezing point or a cooler sections. After that cooled compressed air is passed through the separator, right? After in the separator, the carbon dioxide will be out as a dry ice. Okay, the carbon dioxide is taken out from the separator or taken out from the air, that by in the form of dry ice. So you already know that the dry ice is called as carbon dioxide. Okay, that carbon dioxide is taken out from the separator as a form of dry ice. After that the separated carbon dioxide from the cooled air is passed through the water expansion jet. Okay, after that the mixture of air or a cooled compressed air is passing through the expansion jet of air. It will now will converted into what, a liquid air. Now it is what, hot air is converting into, now will be converted in the expansion jet as that liquid air. In the liquid air we can separate out the here nitrogen separated and argon also separated in the fractional distillation column, and after that the remaining gas is remained as what, our liquid oxygen. So by this method we can easily separate the oxygen from the air, right? How? Again we'll repeat in a small way. Okay, so first we are taken as the air, and we should filter them and pass it through the region of high pressure, and that high pressure will applies the pressure on what, a mixture of air, and the air will becomes very hot, and hot air will passes through the water cooler sections. So the water will cools the hot air, and the cold compressed air is passing through the water separator, and the separator removes the carbon dioxide in the air in the form of water, dry ice. The separator will remove the carbon dioxide in the form of dry ice. After that the compressed air is passing through the liquid jet, and in that liquid jet the air will converted into a liquid air. So in that liquid air, after it will be passing to the expansion jet, they will separate the different gases according to their boiling point. First nitrogen will be removed and argon will be removed with a different sections. It is not mixed with each other, they are separately carried out by the method, and after that laterally we will get the water, a liquid oxygen. So this is called as what, separation of component of air. Okay, so this is called as what, separation of component of air. So we can complete this by two factors. One is increase in increase in pressure. Remember that, increase in the pressure. Second point, you have to decrease the temperature. By doing these two applications we can convert a component of mixture in component of mixture of air. Okay, this is the method. Okay, thank you for watching. Please subscribe my channel, share with your friends. Thank you.